So, just to introduce myself, I'm James McComb. I'm product management lead for the field segment of Yamaha Motor Europe. So that's covering sports touring bikes, of course, also sports heritage, adventure, hypernatives. This is our new CP3 platform chassis. So if you were at the MT-09 launch, you will have seen this chassis used in place on the MT-09. But we have some specific changes just for the Tracer 9. The base mainframe chassis though is shared. This is still a CF die-cast chassis. This process allows us to produce exceptionally thin wall structures, actually just 1.7 millimeters. The frame thickness is just in the knee area, just leg crosses. The frame there is exceptionally thin and is the thinnest aluminium frame structure of any of our bikes, our road bikes so far. Fundamentally, the geometry is pure Tracer. It's still very direct, it's still very agile, but we've lowered the headstock 30 millimeters down as well. And we've made the engine 5 degrees more vertical. So this is to create a completely more compact, mass centralized package. One of the plans with this new Tracer is to bring as much of the mass internally towards the center of the bike, and whatever is remaining on the outside to then make as light as possible. Specific for the Tracer, the engine mounts are tuned to provide the stiffness characteristics that we wanted to get the bike to handle exactly as we need it. So the steel plates that we make the chassis to the engine are thicker, they're slightly more heavy duty, and the bracing plate across the top of the chassis is also specific to the Tracer. This is all about creating improved feeling in the corners, particularly high-load, high-speed situations where you get the biggest flexes on the chassis. Overall, though, the chassis is 50% stiffer than the previous one. Unique to the Tracer, both the subframe and the swing arm. Unlike the MT-09, here we have a tubular steel chassis. This is designed to allow much higher loads than the cast aluminium one in the MT-09. So both Tracers are now capable of full 3-bag carrying capacity. And the payload, total payload as well, is increased by 9% up to 193 kilograms. That's exclusive of the cases. So with the cases fitted, you can add 193 kilos payload, so rider passenger luggage. The swing arm itself is completely different to the MT-09, still aluminium, section welded, but it's 64 millimeters longer. And this is also longer than the previous Tracer. But the wheelbase, the total wheelbase of the vehicle is the same, at 1500 millimeters. We didn't want to extend the wheelbase of the vehicle, rather we made the swing arm longer, tilted the engine up, and made everything a lot more compact. Longer swing arm within the same wheelbase gives you more rear mechanical grip, more stability. The swing arm, of course, is also mounted inside the frame. This is one of the key differences in creating that high-speed, high-load stiffness and stability that you will get. So the swing arm now clamped between the outer frames. As I said before, we've tried to bring mass in to the center as much as possible, and where we can't, that's where we focus the efforts on reducing weight. So our new spin-forged wheels, it's another technique that we've introduced at Yamaha in order for us to make our lightest ever aluminium wheel. Beyond this, we have to go to a magnesium or magnesium forged wheel, which for your average production bike is not viable. So this technique was introduced to allow us to have a very, very lightweight cast aluminium wheel. And we take that casting, and then we, as you can see in the video slightly here, we basically spin it, high speed, we heat it, and we press a roller. And this compresses the rim of the bike and reduces the thickness of the rim to just 2 millimeters, down from what is normally 3.5 millimeters. 1 kilo lighter a set than the previous Tracer. There's no reduction in durability, there's no reduction in the strength of the wheel at all. And just to give you an idea, on the previous generation of bikes, the Tracer had specific wheels to be strong enough, durable enough, whereas now these wheels are identical to those on the MT-09, such as the performance and the durability of these wheels. Coupled with these wheels is a specific tyre. We now have Bridgestone Badlax Sport Touring T32 GTs. The discs, the calipers, are still 298mm discs and our 4-pot semi-monoblock calipers coming from the R1. But we now have a Nissin radial master, allowing much more linear actuation, gives more feeling, more consistent actuation on the front brakes. And linked to this, we also have a Bosch 9.1 MP ABS pump. We'll go through exactly what this allows us to do, but moving from the Advix to the Bosch system has given us a lot more options in terms of braking control. Also, as with every element on this bike, we've tried to get dual function. We've tried to get additional functionality and reduction in weight. And moving to the Bosch, it's also 40 grams lighter. All these little reductions in weight are all adding up for us. The more weight we can reduce in the core of the bike, the more function and specification we can add on to it. In terms of suspension, we are still using a 41mm USD KR4. At the front, it's adjustable for rebound damping and spring preload. Got a specific setting, obviously, for the Tracer. Again, it's all about a balance. Meant to be sporty, yet comfortable ride. It's a little bit stiffer than the previous setup. Damping is more controlled. It allows more body control, less pitching forward and backwards. And at the back we have a KYB monoshock fork with a specific linkage. We have the longer swing arm, so the geometry of the linkage for this bike is not shared with the MT-09. And that shock is adjustable also for rebound damping and spring preload as well. Called the CADS system, which stands for the KR Actimatic Damping System. Actimatic being portmanteau of active and automatic. But effectively what we're doing here is controlling and analysing the damping of both the front and rear suspension live to be able to provide the precise damping control that you need and reacting to whatever is in the road. Not only does the system use its own computer control unit, but we are taking inputs from the IMU, from the engine control, to understand whether we're accelerating, braking, or the brake hydraulic control unit itself. So we're taking all this information from every computer that's on the bike and putting it back into the damping system. And the key is to basically keep the body under control as much as possible in any riding situation. The system not only can obviously change, which you can't do live on an analog suspension system, but it can change far more rapidly than you can imagine. The system is reacting immediately to what is happening. But also, we can have a much wider range of damping variation than on a standard unit. So it can change immediately, but also over a very, very wide damping range. So this allows us to give very specific damping control individually for front and rear of the bike in any specific situation. In order to simplify the system, but also to focus on the damping, we've made the spring preload adjustment manual. So on the rear of the bike you see a remote spring preload adjuster, and on the top of the forks you can also adjust the preload. Typically, spring preload you adjust for the specific riding condition. When you have riding solo or you are riding two up or with luggage. But we wanted to add a level of maturity, sophistication, but just controllability. So the rider has increased confidence in that whatever action they input on the throttle, it's a very reliable, consistent output of the rear wheel. So we still have that excitement, but there's a much higher level of consistency in that connection. So we have 4 Throttle D-Modes. The targets were to not only make that a very pure connection, but also to make a very clear difference between all 3 modes. The mode 1 to 4, on all of our electronics, the lower the number, the sportier the reaction. So there's the throttle modes, traction control, or even the electronic suspension of the GT. The lower the number, the sportier the implementation. So mode 1 is the sharpest response.